Okay, so we're focusing on domain and range. Which one is the x values of a function? Domain or range, which one is the x values of a function?
Domain.
Awesome, thank you, Isaac. And then by default, that means range is the y values. And in this little preamble of my lesson, I have for any relation, the set of values of the independent variable, independent being x, is the domain, and the dependent variable, the y, is the range. When we're evaluating the limitations on a function, we're trying to describe where does the function exist on the graph? Are there places where the numbers, it's impossible to get those end outputs of a function? Are there limitations on where it exists? So the domain, what we're looking for is the values that x can have, or where it exists, what x values the graph exists. And for range, we're looking at the values that y can have, or what y values on the graph the function exists. In grade 10, you guys in quadratics had what's called transformation charts. And you guys actually described, it literally said in the transformation chart, values x can have, values y can have. But now we're attaching the grade 11 words of domain for the x values and range for the y values. If you forget which one is which, x comes before y in the alphabet, d comes before r. So domain is x, range is y, okay? So hopefully we have that kind of solidly in our mind. I'm going to teach you some general ways of writing this using math symbols. For domain, so this is the x values. If there are no limitations on the graph, and I'm going to tell you how you're going to know here in a minute, but if there's no limitations, then the way that you write that is curly bracket x, this funny like curved e, sorry, and then this funny double lined r. In English, this says x is a subset of all real numbers. X is a subset of all real numbers. In grade 11 math, we're still graphing on a real number line. You guys are not going to be working with imaginary numbers at this point. So basically what we're trying to say is there's no limitations. X can be any real numbers that exist on a real number line. There's no limitations to it. It goes to infinity to the left and to infinity on the right, or infinity up, whichever direction the graph is going. So this is something we're going to try to just remember or memorize. That means X is a subset of all real numbers. But if there are limitations on the domain, we actually have to specify what that is. We're first going to still say we're graphing on a real number line, but then we're going to say possibly that x is less than and equal to some kind of a number. So it's less than a number, or it might be greater than a particular number. I'm going to show you guys all of these, so don't worry about that. This will be if there are limitations. And again, for range, same thing. But in this case, range is y. So I'm just going to replace the x with a y. If there's no limitations on the y values, we say y is a subset of all real numbers. But if the range has limitations, we start with the preamble of all real numbers, but it might be less than a particular number, and it might be greater than a particular number. And this, I'm just going to write here, this means subset.
Miss Reed,
Yeah.
could you just explain like what those like under no limitations and under limitation, like what are those little like symbols?
So actually probably is going to be easiest. It's first, guys, take a screenshot of this here just for a minute, because we're actually going to use it. It's easiest to just start using it as opposed to randomly describing these. It looks almost like we're writing Greek. Like, is this English? Is this a real language? But they're just math symbols. So let me know if you still have questions here when we start practicing this. Let me show you what I'm talking about. Everybody, if you haven't taken a picture of that yet, please speak up because I can't see you. 3, 2, 1. Okay, we're going to practice this. Here is a function. y equals 2x minus 5. I'm going to graph it on Desmos, and then we're going to try to see what's the domain and the range of the relationship. So let me switch over to Desmos. Y equals 2x minus 5. We're going to be looking at the graph here. Y equals 2x minus 5. Okay, this is a linear function. You guys can see that, right? If you guys look at this graph, and first we're going to look at just the x values. So the x values is the horizontal line. You can see it crosses here at 2.5, but then as you can see, it continues this way, and it continues this way. And I can zoom out. Are there any limitations on this linear function? Does it ever stop? Is there ever a value where it does not exist?
No.
No.
No, I could do this the whole rest of my life, which I'm not going to do. But you can see I'm like, it just keeps going and going and going and going and going. Okay. There are no limitations on this linear function. So look at what you just put a screenshot on your phones or whatever you guys just did. If I was going to describe the domain and the range of this function, what am I going to write for domain? Try to describe that to me. What does it look like?
It would be like the one where there's no limitations. It would be like the backwards 3xe weird r,
Yeah.
and then the other one.
Perfect. Okay, so it's curly brackets. I know it's curly brackets. It's hard for me to draw the curly brackets. Kind of like that. X, the weird E and the weird R. This means that this function, this linear function, exists on all numbers of the X values that it could ever have. Infinity in the positive direction, infinity in the negative direction. No limitations. What about the Y values? Are there any limitations? Let me go back to that graph for a second on how far it's going in my Y values, which is the vertical axis. Are there any limitations on this function?
No.
No. So what am I going to write for the range?
Miss Reed, I have a question.
Mm-hmm.
What would it look like? Wait, are you going to show us after what it would look like if there was an end?
Yes, I definitely will.
Yeah. Okay, never mind.
That's okay. Yeah, we're going to do this baby steps, Lauren. First of all, this one's nice and easy. There are no limitations. Okay, it goes forever infinity, left and right. It never stops. Any questions on that one? Speak up or forever hold your peace. 3, 2, 1. Next one. Okay. And I'm going to rely really heavily on Desmos just because this gives us a visual picture of what is this equation and where may it exist or not exist. Okay, so you can see this looks quite different. So let's put into Desmos and see what does this graph look like. And Lauren's just waiting, anticipating that maybe there might be some limitations on this. So let's see what happens. X minus 1 close bracket squared plus 3 was the equation. Okay, does anybody know the name of this type of function?
Parabola.
It is a parabola. It's a quadratic function. Great job, Lauren. This is a quadratic function. Okay, let's look at this graph for a minute and let's look at the X values. So X is your horizontal axis. You can think about it like the width of the parabola. Okay, so you can see the vertex is here, but then it's going like this. Okay, and it keeps going. Let's see if there's limitations on how wide it gets. Domain is X, which is left and right, or in this case, we can think about it like width. Does it ever, oops, I'm going the wrong way. Does it ever stop as far as the width of it going? I'm kind of like, it looks like I'm zooming out. Does it ever stop?
No.
No.
No. Awesome. So what am I going to write for domain for this quadratic function? You can just copy it from that. Oops. Sheet. It's going to be curly bracket, X, funky E, silly R, close curly bracket. Okay, I'm just gonna write on here, this one is a linear equation. This one is a linear. Okay, let's take a look at the y values though of this quadratic. So y is going up and down on the vertical axis. Let me go back to centering it. Okay, this is my vertex right here. In this case, because the parabola is opening up, this is my minimum value. It's like a valley, right? What do you think, or where on this graph does the parabola not exist? If I go this way, does the parabola exist down here?
When it crosses the x.
Yeah, good. So yeah, so Alexis, it
Fine.
doesn't exist down by the x-axis, right? So if you guys look at my vertex, if I scroll up this way, you can see the parabola is opening up. It's like it's going into outer space, up, 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 up to infinity and beyond, right? But if I go back to my vertex, does the parabola exist down here? Do you see it down here?
No.
No. So let's take a look at this graph here. What is the smallest y value that this parabola hits before it turns around and goes back up into outer space?
0, 4.
There's that's a y value. Makai, does it have a lower y value?
Yes, 1, 3.
3, awesome. So if you look at this parabola, let's pretend like we are kind of going down into this valley. If I started up here and I went down, 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 the lowest it hits right here is a y value of 3, and then you start going back up the valley again. So there is a limitation. The parabola does not get any lower than a y value of 3. So there is a limitation. So now we have to go over to the limitation side of my notes. And it's one of these. I'm going to start with the preamble of all real numbers because this is a real number line. So my range is y is a subset of all real numbers. Oops, I don't want that curly bracket yet. This straight up and down line means like there's something else that I have to say about it though. So it is a subset of all real numbers, but there's a limitation. Is y greater than or less than 3? So I'm going to go back to my graph. I have to pick this one or this one. Is y less than 3 or is it greater than 3? Let me go back to my graph. Is y 3 and greater or is it 3 and less than 3?
Greater.
Greater. So the second part of my little math sentence here is that the limitation on y is that it's going to be greater than and equal to 3. That means it's 3 and everything bigger. Questions? I'm going to put here, this is greater, because often I find we forget which one's which, and this is less. One thing I should mention to you guys is I do always post the PDFs of my lesson afterwards. So if you're just watching and following along, that's fine. I'll post the PDF, okay? So then you have these notes. We're gonna try this one. Whoa, this looks weird. I don't even know what this is gonna look like. Does anybody have a guess?
Wait, can you go back for literally like one
Oh,
sec?
sure.
I just
Yeah,
need to find the last one.
No problem. Give me, just let
Okay,
me know.
perfect. Thank you.
You're welcome. Let's try this
That's
one.
good.
Okay, awesome. Let's graph this because we don't have any idea what this is going to turn out to be like. So I have, yes, Makai, what's your question?
When we're figuring this out, do we have to use Desmos?
No, I'm
Or are we
actually
going
going
to be using?
I'm actually going to be giving you the pictures today. And if it's any kind of evaluation, like a paper evaluation, Makai, I always put a picture there, but actually you'll use Desmos quite a bit with our online classes.
Okay.
So I'm not going to have you hand graph anything, okay? All right, I have to put x minus 1 underneath the square root sign there and plus 3. All right, this looks weird. Has anyone seen anything like that before? So it is definitely a function. If I passed a vertical line through it, it's only going to cross through once. So let's take a look at this function. Look at your x values. So let me just zoom out a little bit here. Are there limitations on how far left and right this function goes?
Yes.
Okay.
No. Yes.
Yes and no, Lauren, you're actually right. Does it
Okay, good.
exist? Does it exist left of this point?
No.
No. However, look to the right. Are there limitations on how far it goes to the right?
No.
No. So this is a really weird one. Okay, so let me just go back to home here for a second. Let's think about this. For sure, x is a subset of all real numbers. We know that. How am I going to write that it exists everything to the right of, and I'm focusing on my x values, so in this case, 1. Is it going to be greater than 1 or less than 1?
Greater than?
Yes, perfect, Lauren, because if I look at my points, it starts here at 1, and then it just keeps getting bigger and bigger and bigger. I get to 6.45, and I could keep going. So it's going to be greater than 1, but not less than 1. It does not exist left of 1. Can everyone see that? So I'm going to put in my notes, domain is a subset of all real numbers. And Lauren said x is greater than and also equal to, it does exist at 1, and it's everything greater than 1. Questions on that one, guys?
What's the x after the line? What does that mean? Yeah, that. What does that mean?
So this straight line here, Makai, means yes, x is a subset of all real numbers, but there's limitations. X is greater than and equal to 1. Let me go back to your graph again. So if I look at this graph, this function starts at 1, and then it goes to the right, which means it's getting bigger and bigger and bigger as I go to the right. It's greater than 1, but it does not exist less than 1. So x is greater than and equal to 1.
Okay.
Okay. Let's look at the y values now. So does the function exist less than 3? Does it exist down here?
No.
No. So definitely it does not exist less than 3. Let's look at greater than 3. Are there any limitations to the y values? I'm going to have to zoom out really far, I think. It's hard to tell. It is increasing slowly. Like here it's at 28, 29, 30. It is increasing slowly. 41. Does it look like there's any limitations on y? Now it's at 50. Does it look like so it definitely doesn't go less than 3. Does it look like it has any limitations on how big it can get? It's just increasing really slowly. That's 110. I think it exists forever and ever and ever to infinity and beyond. It's just a really, really slow increase. So it looks like the only limitation on y is that it is going to be 3 and everything bigger than 3. Can you guys see that with my y value, the second number?
Miss Reed.
Yeah, Lauren.
For the domain, if it was less than, like the end was x, like less than 1, would the whole thing be going the opposite way?
Just this switches, just this one symbol right here.
Yeah, but like would the whole like line on the graph go the
Yes.
different way?
Yes, it would.
Okay.
Yeah.
Thank you.
You're welcome. Okay, so with the range, we just said, okay, we're always going to write it's all real numbers. and we said y is greater than and equal to 3. It does not exist less than 3. Actually, what I can do is I'm going to input pictures of the graph too, so we have that in our notes. Let me grab this. Okay, we're going to look at a couple more functions. Any questions so far on what we're doing here? You're looking at the graph and just trying to determine if there's any kind of limitations that exist. You're going to have to, if you have questions, you're going to just have to ask them or pop into Math Help too. I'm happy to do that as well. Let's try this one. This looks weird. Again, it's like, oh, now we have a kind of a different thing we're looking at. X squared plus y squared equals 36. X squared plus y squared equals 36. So this one made a circle and actually not a function. Let's see if there's limitations on this though. Look at the X value. So I'm looking at my horizontal axis. Are there
We can't
places?
see-
Oh, thank you, Makai. I forgot to switch my screen share. Thank you so much. Okay, now that you can see something, are there limitations to where this circle does not exist? Are there values where it does not exist? Look at your
Yeah.
X axis. Okay, what are you thinking? Where does it not exist?
Like it's not at like plus 10 or minus 10 or 15.
Awesome. Okay, good. So it only exists between -6 and 6, right? On the x-axis. It only exists between -6 and 6. Can you guys all see that? This one is
Yeah.
a little bit trickier to write. So you'll probably want to take a look at these notes when you're doing your worksheet later on today. Let me just take a copy of that. Let's figure out how are we going to write this in math terminology. It only exists between -6 and 6 on the x-axis. So domain is, I'm just going to abbreviate that to D, all real numbers. And this one is that your X value exists between -6 and 6. It's greater than -6 and less than +6. So it only exists between -6 and 6. Here's the good news. You always write them smallest number on the left, biggest number on the right, and your less than symbols both pointing toward the left like this. So smallest number on the left, because that's on the left side of my graph, biggest number on the right. So this is saying X only exists between -6 and 6. Questions about that one? Who wants to be bold and tell me then what they think the Y values would be for this circle? What am I going to write for my range?
6 and -6.
Yep. So basically it's the exact same thing, right, Tegan? But what's the only thing I'm changing from what I wrote with the domain?
The first 6 is positive and the second one's negative.
Yeah, it still will be -6 and 6, but what's the variable here going to be for range?
So it's gonna be y.
Oh, why?
Awesome. Nice job, girls. Okay, good. So literally it's the same, except for now I'm going to say, actually, the same exact limitations happen for Y. So just a little note, you still want the smallest number on the left, biggest number on the right. Maybe I'll just write a little note here. Smallest number on left, biggest number on right. Any questions on that one? The circle itself is probably not complicated as far as like you can see it doesn't get any bigger than 6. It doesn't exist at 7, 8, 9, 10, any direction, up, right, down, or to the left. It's just a matter of figuring out how to write it in math symbols? Questions on that one, guys? It's a bit of a tricky one. Okay, here, now we have another weird function. This is our last one we'll do, and I'll give you guys some time to practice. Let's put this into Desmos and see what does this crazy equation look like. All right, so I have y equals 1 divided by, I don't know if I need brackets, but I'm gonna try x plus 3 close bracket. Look at this one, guys. Okay. This one may take some analysis here. Let's look at our x values. So I'm looking at left and right. Are there any numbers where x does not exist?
No.
Please do.
Oh yeah. Like
Was it-
between 0 and minus. Oh.
Yeah. Can you guys see the line that goes straight up and the line that goes straight down?
Yeah.
Do they actually meet at the same number? Does it look like they
No.
actually no, this is weird. So I'll actually tell you, it actually never touches -3. This line right here, this -3 line, actually, let me put in here, x equals -3. I'm gonna zoom out and I'm hoping you guys can see that it never will touch that green line. It's a little bit hard to see, but if I zoom in, can you guys see it actually never touches? Even though it looks like it touches it, it doesn't actually touch it. Can you guys see that? This is a weird word in math. It's called an asymptote. It's a line that a function approaches but never touches. So I'm going to put that in our notes because it's a weird line here. X does not, it's literally everything except for that asymptote. It is not going to exist at -3. It goes infinity to the left and infinity to the right. Like it goes this way and it goes this way. The only place it does not exist is at -3. Can you guys see that? Or questions on that? We're learning so many new terms today. It's mind-boggling.
What's an isotope again? It's like
It is a line
one in the
that,
line.
yeah. So actually, Mikhail, let me put that in our notes. I'll put it. Give me 1 second. I'll type it out for you guys. Oops. Let me just insert this though. Okay. So it's spelled very weird. It's an asymptote. And I'm going to show you guys this because this is going to help you remember what this word means. Anyone Lord of the Ring fans? So this is Gandalf here, and you'll probably remember the scene where he yells, "You shall not pass," and he stabs the staff in. This is trying to show you that this is an asymptote. It's the line that the function approaches but cannot cross. Okay, hopefully that helps you guys remember that. So we're gonna go back to this question. Who thinks they can tell me how to write in ridiculous math symbols then that x exists everywhere except for at -3? How are we going to write this domain?
I'll try, but I won't get it right,
Awesome.
but-
Lauren, I love it. I love your bravery. Okay, so what's the domain? What do you think I should write here?
So it's like open bracket,
Yep.
X, E, R, and then line.
Okay.
And then less than -3
Okay.
or greater than.
So Lauren, do you remember in math, like obviously if we solved an equation, we go like that to say it equals. How do I make this so that it looks like doesn't equal?
I don't know, put a line through it.
Exactly. So actually here, all I have to do is say that x just does not equal -3. That's the only limitation that
Oh.
exists. Yeah, it makes it a little bit easier than trying to say it exists from -infinity to +infinity, but not -3. All you have to do is say, actually, there's the only limitation is that x just can't equal -3. Everything else is fair game. Okay? Any questions on that, guys? Let me go back to, some of you guys are silent. I'm hoping you're still following along in this lesson because this can be a little bit complicated to do if we have questions afterwards. So let me close that up. Let me go back to our graph here. What about y values? So if you look up and down on the y-axis, does it exist everywhere up and down on the y-axis?
Yes. Oh no, not above the x.
What does it not touch? So if I start going, let me zoom out a little bit. Because if I come down, 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 what number does it not touch? So it's going -2, -1. What y value? And now it's at 0.95, 0.85. What number does it never touch? Anyone want to guess? It's getting smaller and smaller and smaller. I'm at 0.74. What number, what y value does it never touch?
0.
0. Awesome. So let me go back to home here. Thank you, Alexa, for guessing that. So if you guys look, it goes from infinity up, but then it curves. It never hits 0. And right here, it comes from the left. It comes from close to 0, but never 0. And now it goes infinity down. So it never touches 0. Alexa, do you want to take a guess at how I'm going to write that range then?
I'm not sure.
So it's every number except for 0. How do we write that? Every number, but does not equal 0. Follow the.
Is it like y?
Yep.
Sorry.
Yep. No, it's great.
Is it like y with equals crossed out 0?
Yeah. Exactly. Y is everything except for 0. Fantastic. So I know this is a concept that's it's new as far as like trying to analyze things that are not quadratics. You're just looking at a random variety of functions and trying to describe based on the graph, where does this function exist and what limitations currently are there.